Hello and welcome to 4.4 part 1, which is solving trigonometric equations. So there's two parts to this section. Part 1, we're going to be solving equations that have a finite set of answers. Next lesson, we will be doing part 2, which is solving using a general solution, all possible answers that exist, that if we do not have a finite set. Okay. So first, the question is saying if theta is between 0 and 2 pi. So this essentially means if we're starting on our positive x-axis and our terminal arm is going to complete one rotation or one circle, which is 2 pi, what angles are possible in that one circle? So we have secant theta is equal to -2. Now we know if this is true, then cosine theta must be the reciprocal of this, which would be 1 over -2. Now, when you are doing these, the first thing that you're going to want to do is draw yourself a picture. Pretty much every time, unless you are given an additional set of information, you should have two terminal arms in two quadrants. And this is because every trig ratio is positive in two quadrants and negative in two quadrants. So unless you are given some additional piece of information to narrow that down to just one single quadrant, you should have two answers, two quadrants, and two terminal arms. I'm going to draw myself a picture of what this would look like. So if cosine is negative, we are in Q2 and Q3. Okay. Now if we draw in our triangles, we know that adjacent is 1 and hypotenuse is 2. Now something's supposed to be negative. We know it can't be the hypotenuse, so it would need to be the adjacent. Now as soon as it says exact value, we know that we should be using special triangles. You don't have those memorized yet, you need to. Okay. You have two special triangles. If it helps to write them on the top of your page, do so. So your two special triangles were pi over 4, or 45, 45. This was the 1 root 2. The other one was your 30, 60, 90, or pi over 3, pi over 6, and 90. And this one was 1, 2, root 3. Okay. You need to know these, right? So I can see I have a 1 and a 2, so that means my other side must be a root 3. For my lower triangle, that must be a negative root 3 because y is negative down there. And now I can determine my reference angle. So remember, your reference angle is this lower corner in here that attaches to your x-axis. And for us, our reference angle is across from root 3. This means our reference angle must be pi over 3. So in quadrant 2, our theta is going to be pi minus pi over 3, which would give us 2 pi over 3. Right? So if I started pi would be a half rotation, but I didn't quite go that far. I was the reference angle short of that. Quadrant 3, our angle is going to be pi plus pi over 3. I traveled my half circle plus a little further, and the little further is pi over 3. And this would give me 4 pi over 3. So I have two possible answers here. Okay. If you want to try the next one on your own, you can. I would pause and then proceed. But before you do so, just a reminder that root 2 over 2 is a rationalized version of -1 over root 2. So this is negative root 2 over 2. This is the same as -1 over root 2. So again, knowing those two are equivalent would be very helpful for you. Especially if you're not comfortable with rationalizing, I would memorize that those are equal. Okay. So you can go ahead and try this one if you'd like. You can pause. If you're continuing on with me or you're now looking at your answer. So again, we're doing one rotation. Sine is negative in quadrant 3 and quadrant 4. It didn't tell me to use exact values, but as soon as I noticed that this is part of my special triangles, I could see I've got a 1 and a root 2 for my pi over 4 special triangles, so I should be using special triangles here. I've got Q3, Q4. And again, we know our reference angle usually falls in here. Sine is opposite over hypotenuse, opposite, hypotenuse, opposite, hypotenuse. We know in both these quadrants that opposite is a y value and should be negative. And our other side from our special triangles is also a 1. In the right-hand triangle, that adjacent side will be positive. In the left-hand triangle, the adjacent side should be negative because our x's are negative here. Now I can see that our reference angle would be pi over 4 from our special triangle. In quadrant 3, our theta is pi plus pi over 4, which would give me 5 pi over 4. And a reminder that this would be if we were traveling from here to here. In quadrant 4, we would be traveling from our positive x-axis all the way around to that terminal arm there. And so in quadrant 4, this is going to be 2 pi minus pi over 4. I traveled just a little bit short of a full circle, and I was short by pi over 4, and this is 7 pi over 4. If you're not that comfortable with adding or subtracting from pi, just a reminder that if you make common denominators, this would be a lot easier. For example, pi is the same as 4 pi over 4, and 2 pi is the same as 8 pi over 4. And that might help you with the adding or subtracting of things like pi over 3, pi over 4, and pi over 6. So a couple steps here. 1, identify the correct quadrant or quadrants. 2, find the reference angle using SOHCAHTOA, so label a triangle there and then find out what that reference angle is. And then you need to find your actual angles using addition subtraction. So you're either adding or subtracting from pi or 2 pi. Okay. When you're solving for your reference angle, a hint would be to ignore a negative sign. Okay. And that will just go straight to your reference angle, as we saw with 4.3 part 2. We use the negative from our ratio in our calculator. What will happen is we will get a negative answer or an answer in a funny quadrant. And so if you ignore that negative sign when you're plugging into a calculator, it'll just pop out the reference angle. So for example, if I have cosine of negative 1/2 and I do inverse cosine of negative 1/2 in my calculator, it will pop out an actual theta. If we do inverse cosine of positive 1/2 in our calculator, it would pop out a reference angle for us to use. Okay, that's what this is talking about. Also, we want to answer in exact values wherever possible. So unless a question gives us permission to answer in hundredths or whatever, we're going to assume to use exact values. If we can use special triangles, we will. So that was like example 2. It didn't tell me to do that, but it was possible to use a special triangle, so that's what I did. We're going to do a couple more questions here that are a bit more complicated. All right. So the first one here is asking us to solve 3 tan theta plus 5 equals 0. And we are being told we are in degrees here. So first, I need to know what tan theta is equal to. So I need to isolate tan theta. So I'm going to subtract 5 from both sides. And then I can divide by 3. So I get tan theta is equal to negative 5 over 3. I know that tangent is negative in quadrant 2 and quadrant 4. So if I draw myself a picture, we'd be in quadrant 2, quadrant 4. Tangent is opposite over adjacent. And in this case, in the left-hand triangle, the 3 is negative. The right-hand triangle, it's actually the 5 that is negative. Now here, this is definitely not a special triangle, so I'm going to need my calculator for this. I'm in degrees mode here as per the domain given in the question. So this is what it meant by you can ignore the negative here and pop out a reference angle. So I know that tan theta is equal to -5/3, which means that the inverse of tangent of -5/3 will give me one of those angles. If I want to find the reference angle, I can simply remove the negative from in those brackets and do 5/3. Now, when I do that, I'm going to get my reference angle is 59 degrees. And this means in Q2, this is going to be 180 minus 59, which is 121. And in Q4, I'm going to get 360 minus 59, which will give me 301. So I still have two answers, but I'm in degrees here. And I needed my calculator to find my reference angle because it was not a special triangle. Now you might also see something a little bit more complicated. Okay, these ones, obviously the value of cosine and sine have not been given to you. You're going to need to use your ability to solve a quadratic in order to solve these. If you prefer, you can replace cosine theta, sine theta, etc. with an x, solve for x, and then proceed. Okay? So what I mean by that is I can say let cosine theta equal x. Okay? Then here I now have 2x squared equals root 3x. So I'm replacing this cosine with an x and this cosine with an x. Okay? A little notation thing that cosine squared theta is the same as saying cosine theta all squared. It's the ratio that is being squared, not the angle. Okay, so it's not like cosine of 30 degrees and you're squaring the 30 degrees. You're squaring the ratio that cosine theta equals to. Okay? Now, once I do this, I can solve this quadratic. So just a reminder, you cannot just divide by x. When you're solving a quadratic, your first step is move everything over to one side and then to factor. So if I subtract my root 3x from both sides, I would get this. Now I can factor an x out. So this means that either x is equal to 0 or 2x minus root 3 is equal to 0. Okay. X is equal to 0 is already solved. 2x minus root 3 is equal to 0. We can rewrite as 2x equals root 3 or x equals root 3 over 2. Now, you are not done. You have not solved for theta. You found an x. There wasn't even an x in your question. So we must put the cosine theta back in. So this is actually cosine theta equals 0, and this is actually cosine theta equals root 3 over 2. So now cosine theta equaling 0, this is a special angle. Okay. So when we have our quadrant system, cosine theta being 0, we know that that's adjacent over hypotenuse. So this means the adjacent must be 0. Hypotenuse can't be 0, right? If adjacent is 0, reminder when you draw in a triangle, we're going to erase this in just a moment. We have our theta in here. This would be adjacent, opposite, and hypotenuse. Our opposite is always a y value, and an adjacent is always an x value. So if adjacent is equal to 0, then x is equal to 0. That means that if your x is actually 0, you are not on a triangle, but in fact on an axis. Where is x equal to 0? X is equal to 0 here or here. So if cosine is equal to 0, we're on one of these two axes lines. And that must mean that theta is equal to pi over 2. That's the positive y-axis, or 3 pi over 2, the negative y-axis. The other answer, the cosine theta equals root 3 over 2, we have to solve completely separately. If cosine theta is root 3 over 2, that's positive, we're quadrant 1, or quadrant 4, adjacent, root 3 over 2 hypotenuse. We know this is a special triangle. Our opposite would be 1. For the negative triangle, this would be a negative 1. And our reference angle here would be pi over 6. So our quadrant 1 answer is pi over 6. Our quadrant 4 answer is 2 pi minus pi over 6, which is 11 pi over 6. So I have 4 answers. Theta is pi over 2, or 3 pi over 2, from our x equals 0, or cosine theta equals 0, or pi over 6 and 11 pi over 6 from our x equals root 3 over 2, or cosine equals root 3 over 2. So for these quadratic ones, you could have as many as 4 different answers. Now, it might be helpful to memorize the quadrant line trig ratios. So if you are on the positive x-axis here, cosine theta equals 1, sine theta equals 0, and tan theta equals 0. You're on the negative x-axis, cosine theta equals negative 1, sine theta equals 0, tan theta equals 0. On the positive y-axis, cosine theta equals 0, sine theta equals 1, tan theta does not exist. The negative y-axis, cosine theta equals 0, sine theta equals negative 1, and tan theta does not exist. So these are all special ones. If you don't have these memorized, you know how to figure them out, that's fine. But if you don't, I would memorize these 4 axes lines, the 3 primary trig ratios. There's one more example here. If you want, you can pause and try it on your own. If you're not ready for that, you can continue with us. So again, I'm going to say let sine alpha equal x. So instead of having sine squared alpha, I'm going to have x squared equals 3x minus 2. As soon as I see a quadratic, I know I need everything on one side, make it equal to 0, and then I can factor. So this would be x squared minus 3x plus 2 equals 0. If I factor this, I get x minus 1 and x minus 2 equals 0. This means x equals 1 or x equals 2. I need to replace my x's with my sine alpha. I had no x's in my question, so I must continue by actually finding my angle here. So this would be sine alpha equals 1 or sine alpha equals 2. Now, sine alpha equals 1, as soon as I see that, I know I'm in one of my special cases here. Okay. Sine alpha equals 1 on the positive y-axis only. And again, that's because sine of an angle is opposite over hypotenuse. My opposite is always y. My hypotenuse is the radius of some circle. In order for this to equal 1, my y and my r must be equal to each other, which means they must have overlapped, like it's a collapsed triangle. Okay? And the only way that this works, because we know that x squared plus y squared equals r squared for any of our triangles, if y and r are the same as each other, x must be 0. Okay? So in order for this to happen, if x is 0, I have to be on either the positive y-axis or negative y-axis. And because it's equal to positive 1, I must be on the positive y-axis. So this means that alpha, my angle, is equal to pi over 2. Okay. Now our second set of answers, okay, this is not possible. Now if we think about this, what we just talked about, we know that sine alpha is equal to y over r, and we know that x squared plus y squared equals r squared. So if it's y over r and it equals 2, then that means y is bigger than r, which is not possible. It's not possible for y to be bigger than r because in our triangles, we have y, x, and r is a hypotenuse. R has to be the biggest. So sine theta and cosine theta can never be bigger than 1. Okay? The only reason 1 works is when we're talking about no triangle, but actually a collapsed version of a triangle on an axis line. So you can equal 1, but that's the biggest. Tangent can be bigger than 1. So it's only sine and cosine. Our ratios cannot be bigger than 1. Okay, so we actually only have this one solution. Okay, and that's all for today. Okay, again, you can scroll back if you need. And the next lesson, we will be looking at what if we don't have a finite number of solutions, but we have an infinite number of solutions.